Hello everyone, today we're going to look at usaco-training party lamps. Okay, so in this problem we're given that we have n colored lamps and they're numbered 1 to n. Okay, so the lamps are connected to 4 buttons. So button number 1, when this is pressed, all the lamps change their state. So then all lamps, if they're on, they turn off, and if they are off, they turn on. Okay, so for button number 2, it changes the states of all the odd number lamps. Button number 3 changes the states of all even number lamps, and button number 4 changes the states of the lamps whose form is in the form 3k plus 1. So it'd be like 1, 4, 7, 10, and on. Okay, so originally C, which is the number of button presses, is set to 0, and then all lamps are on. Okay, so then we're given the value of C and the final state of some lamps, which means that we have some constraints that some lamps have to be on in the end, and some lamps have to be off after the C button presses. So we're supposed to determine all the possible configurations of those n lamps. Okay, so for this example, we're given C equals 1, so we're going to use 1 button press. And then we have no constraints for the lamps that be on, and we're given a constraint that 7, or lamp number 7, has to be off. Okay, so we just put them one by one. Okay, so for the first example, since all of them are on, we can choose to use button number 1 to turn all of them off. Okay, so for button number, we can also choose to use button number 2, where we change all the on number lamps. So then lamp number 1, 3, 5, 7, and 9 would be turned off. Okay, so our third possible answer is to use button number 4, where we change these states. So then 1, 4, 7, and 10 would be turned off. I noticed that we can't use button number 3 because using this, lamp number 7 would still be on and it wouldn't satisfy this constraint. Okay, so then also if there are no possible configurations, we just print impossible. Okay. So then you realize that C is in the range from 0 to 10 to the 4th. So it would not be possible to use all possible combinations of the lamps. But the observation is that if you use 2 buttons that are equal, or if you repeat using a button press, then it will just end up to its original state. So let's just say we have 1, 0, 1, 1, 0, and you use button number 1. So then you would get 0, 1, 0, 0, 1 because all the bits invert. Okay, so and then notice that if you use it again, you get 1, 0, 1, 1, 0, and since these are identical, using a button twice just like has no effect on the state of the lamps. So then you know that you have button number 1, 2, 3, and 4. So for button number 1, you can either not use it or use it. For button number 2, same thing goes, and same thing goes for 4. So then notice that since we have 2 configurations for this, 2, 2, and 2, there's only 2 to the 4th possible configurations of the lamps. Okay, so now basically we can simulate using all these 16 buttons, or all these 16 button configurations to make our state. But now we need to check if that state works or not. Okay, so first thing we need to do is, so we have our lamp state, let's call this here. Okay, so first thing we need to do is we need to check if it satisfies the constraints. So we have to make sure that the lamps that have to be on are on and the lamps that have to be off are off. Okay, so after that, it may not exactly fit because there might be like some, like for example, if you have to use two button presses, but you only have one button press and you get this specific state, then this wouldn't work because you can't like change it without altering the state. Okay, so the thing is that, okay, so we used a few button presses. Okay, so we used, let's just say, because out of these four, let's just say we used three button presses. So we used three presses. Okay, and our C is currently 10. Notice that you can't really use this state because no matter how you apply this, you can't make this state again by using another 7 moves. So then, basically, if C minus the number of presses, if this is even, then this is possible, because if it's even, then you can basically repeatedly use the same button to keep this state the same. Otherwise, then you wouldn't just count this. Okay, and this overall solution would run pretty quick because the constant factor of 16 is actually pretty small. Okay, so actually this problem is called party lamps. Okay, so party lamps. Okay, so let's include bits. Okay, so we're going to have n and c, so we can have int n and c. So let's read those. Okay, so we have a list of the lamps that have to be on and a list of the lamps that have to be off. And so we can use a vector of integers. So I'm just going to use this type definition. And using this type definition, in place of anywhere I have to use vector int, I can just use vi instead. So I can do vi on and off. Okay, so then let's call this our temporary like lamp. So we have to first read it, and we just keep on reading until it's not -1. Whoops. Okay, well, it's not equal to -1. You just push T, and then you just read it again. And yet again, you just start reading it for the off. Then, okay. So now basically you have to DFS all those 16 possible combinations. So what we can do, we can make a function. Okay. So let's call this void DFS. So the first thing it should take is the current state of the lamp. So we can do VIA. Let's call this lamps. Okay, the second state, or the second parameter, is how much buttons we press. So it would be int, let's call this CNT. The third state should be if we use the first button or not. Let's call this bool A. And again, we have bool B, bool C, and bool D. So all these A, B, C, D represents the 4 buttons, if they're pressed or not. Okay. So basically, first thing we need to check is if the count is greater than C, then we can just return, since you can't use over C buttons. Okay. Otherwise, basically, if what I do? Okay, so if C minus count, so basically if this is even, so if this mod 2, if this is equal to 0, then you know that this is usable. Okay, so now basically we need to check if this configuration works. So let's make a check function. So this should check, let's call this, we should again take in the lamps. So basically for each element in our on ones, if lamps of X is off, then you have to return false, since this lamp has to be on. And same thing goes for the other side. So off. So basically, if lamps of X is on, then you would return false. Otherwise, you just return true. Okay. So now, basically, if check of lamp, so if this check passes, then we can just push this into our answer. So I'm just going to use a set of vector integer for my answer. So let's call this answer. Okay, so just answer the insert lamps. Okay. Okay, so now basically we have to simulate using the 4 button presses. So basically, if we haven't used the first lamp, we can use it, and let's actually make a function to like configure this. So we can do vi, let's call this a. So this means using button number 1. So this should take in, let's just call this x. So basically, for each element from 1 to n, we're going to invert this. So x of I would be equal to 1 minus x of I. Then you would just return x. Okay, so that's for button number 1. So let's write the function for button number 2. Okay, so this should make it for the odd number. So instead of each time incrementing it by 1, we increment it by 2. Okay, so now let's simulate using button number 3. Okay, so now instead of doing it for the odd numbers, we do it for the even numbers. So we start from 2, okay, and we still increment it by 2. Okay, let's use button number 4. Okay, so we start from 1, but this time we increment it by 3 every single time. Okay, so now basically we just DFS for A of lamps. We increment our count, and A would be equal to 1, B, C, D would stay the same. Okay, so we do similarly for B, C, oops, okay, C, and D. Okay, so we have C and D. Okay, so now what we need to do is we need to call this function. So let's call this our original state of lamps. So originally it should have it should be all 1, so we initialize it to 1. Okay, so now we just DFS lamps. We start from 0, and then we actually don't use any lamps at the beginning, so we have 0, 0, 0, and 0. Okay, so basically now, if answer.size, if there's nothing in it, then we just see out impossible. Oops, end line. Okay. Otherwise, basically we print out the configuration. So we can do basically for each vector, let's call this x in answer, for int I equals 1 to n, we print x of I, then we print n line over here. Okay, so let's run this. So run main. Let me get the input. Okay, still compiling. Okay, so it says impossible. Okay, so we're going to try to simulate using this and that. Okay, C minus CNT. Okay, so here is the error because okay, so this is basically our C, but I'm actually redefining it over here, so I shouldn't do that. So I'm just going to make this capital C. Instead of over here, I should make capital C here too. So then now I'll also read capital C. Okay. Okay, so there's an error. Okay, so I did make a function, so let's just call this another one. Let's call this CC. Yeah, because I'm redeclaring the variable in this function. Okay, this should be CC. Okay, so I think that looks good. Okay, so I have to read from lamps.in, lamps.out, right, and std out. Okay, so I'm just going to submit this. And the language is C++11. Okay, here we go. Okay, yeah, so over here to the problem statement. Okay, let me select it. Okay, so this is party lamps. Okay, so it looks like that is right. Because yeah, if you have any questions, feel free to leave them in the comment section below. Bye.